So quartiles can be used to describe data. Once we know what a quartile is, we can now use it to measure stuff about the data. So the first idea that we want to talk about is known as the interquartile range. And that's calculated by taking Q3 and subtracting Q1, or in other words, the difference between the 75th percentile and the 25th percentile. So this says that the middle 50% of your numbers are between these two values. So 50% of your numbers will be bigger than 50% of your numbers will either be smaller than or bigger than this range. But it tells us basically, okay, half of our numbers are this far apart. This is more resistant to outliers than just a standard range is. Because the range, if you have an outlier, the range just goes from lowest to highest, so an outlier includes this massive range. The interquartile range kind of ignores the biggest and smallest few numbers, so it's more resistant to that. And so because of that, we can actually use this to identify potential outliers. And this uses what we call the 1.5 times IQR rule. So 1.5 times the interquartile range. So you take the interquartile range, calculate that, multiply it by 1.5, and if you have a value that is greater than Q3 plus 1.5 times IQR, then that's probably an outlier. Likewise, if you have a value that is less than Q1 minus 1.5 IQR, then that's also potentially an outlier. So this doesn't say you can just get rid of it. It says if you want to use this rule, here's a good set of things that are likely to be outliers. And this is because they're so far away from those quartiles that they're not matching the same spread. So if all of our data is roughly kind of distributed in a kind of typical fashion, then these are way outside of that typical fashion. This is just a rough rule. It's not solid, but it is one of the rules you can use to identify outliers. Okay, we've talked about a lot of numbers. Now we want to talk about the 5-number summary. So if you're talking about data, one of the ways we talk about the spread is by presenting 5 numbers. The minimum, the maximum, the first quartile, the median, or if you prefer, the second quartile, and the third quartile, or Q3. So this gives us a rough idea of the shape of the data, and this can be depicted using a box plot, or sometimes called a box and whisker diagram. So the way that we make a box plot is we draw a rectangle from Q1 to Q3. So whatever your Q1 value is, that's one side of the rectangle. Q3 is the other side. You're going to divide the rectangle at the median, so just draw a vertical line at the median. Then you're going to add a line from the minimum to Q1, and then add a line from Q3 to the maximum. And this, I'll do an example for you because that'll help lock this in place, but this shows all of that data and it depicts it visually, so it's kind of easy to track with it. So this shows how spread the values are. So for example, if my numbers are a minimum is 10, Q1 is say 15, the median is 18, Q3 is 19, and the max is 23. Well, then what we're going to do is plot those out pretty roughly here. So 0, 5, 10, 15, 20. So first I go from Q1 to Q3 from 15 to 19. Yeah. So some 15 all the way up to 19. So I draw a rectangle. Then I divide it at the median. So the median is right here. And then I draw a line from the minimum to Q1, or to my rectangle, and we typically cap it off so it's easier to tell where the line ends. And then this should go up to 23, which is right about there. So we can see on here, this range right here is all the numbers that fall into below the first quartile. This right here is between the quartile and the median, between the median and the quartile 3, and etc. So this shows us how spread they are, because for example, if you have something like this, this tells you almost all the numbers are in the middle here, because like the numbers are really close together because they have a very small interquartile range. But it also tells us there's some really spread out numbers, and there's probably only a few out here. If I have something like this, it means my numbers are concentrated towards the upper end, because I can see that, again, this represents 50% of the values. So 50% of the values are up quite close to the top. And there's all sorts of ways that as we practice and play with this, you'll be able to understand what this is telling you. But I just wanted to give a couple examples so that you kind of see what we're looking at.